Welcome to Across the Globe. Today, we will learn about concurrency in Python. Concurrency in Python enables multiple tasks to run concurrently, enhancing program performance by efficiently utilizing system resources. Python offers different approaches like threading, multiprocessing, and Asyncio to achieve concurrency. For instance, using threading can be beneficial for tasks involving I/O operations, while multiprocessing is ideal for CPU-bound tasks. Asyncio is favored for asynchronous I/O-bound operations like web scraping or API calls. Ultimately, selecting the appropriate concurrency method in Python depends on the nature of the tasks and the desired efficiency. Threading enables multiple threads to execute concurrently in the same process. Each thread runs independently but shares the process's memory space. In the provided Python example, two threads are created using the threading module to print numbers simultaneously. The print numbers function is defined to print integers from 1 to 5. Each thread, T1 and T2, is then started to execute the print numbers function. This results in both threads running concurrently and independently, producing output where numbers from 1 to 5 may interleave. Multiprocessing enables concurrent execution of multiple processes independently, with each having its memory space. This allows for efficient utilization of computing resources. In the given Python example, two processes, P1 and P2, are created using the multiprocessing module, each executing the print numbers function concurrently. As a result, numbers 1 to 5 are printed by both processes concurrently. This aids in leveraging the capabilities of multi-core processors effectively to enhance performance in various applications. Asyncio is a Python library facilitating asynchronous programming, enabling concurrent execution of tasks without threads or processes. In the given example, we define an asynchronous function, printNumbers, that prints numbers 1 to 5 with a 1-second delay. By using await asyncio.sleep1, each number is printed asynchronously, showcasing Asynsio's functionality for non-blocking, parallel task execution. Concurrency in Python is like having multiple chefs preparing different dishes in a restaurant kitchen at the same time. Each chef is focused on their own task, but they are all working together to get all the meals ready efficiently. Just like how the chefs communicate with each other to coordinate and make sure everything is served on time, concurrent Python programs use threads or processes to handle multiple tasks simultaneously. By utilizing concurrency, Python programs can perform multiple operations at once, making them more efficient and responsive. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code snippet demonstrates the concept of concurrency in Python using threading. 1. We first define a function cookDish name that simulates a chef preparing a dish. The function iterates through 3 steps of cooking the dish, with a 1-second delay between each step. 2. We then create 3 separate threads, chef1 thread, chef2 thread, and chef3 thread, each assigned to cook a different dish, pasta, steak, salad, respectively, using the cookDish function with the corresponding dish name as an argument. 3. Next, we start the threads concurrently by calling start method on each thread object. 4. The main program then waits for all threads to finish executing using the join method on each thread, ensuring that the main program does not proceed until all dishes are prepared. 5. Finally, a message, all dishes are ready, bon appetit, is printed, indicating that all dishes have been successfully prepared by the chefs. Concurrency in Python allows for tasks to run simultaneously, enhancing the performance and responsiveness of applications. In this scenario, using threading enables multiple chefs, threads, to work on cooking different dishes concurrently, similar to a restaurant kitchen, where chefs collaborate to prepare multiple orders simultaneously. Another real-world example of using concurrency in Python is in web scraping. Imagine a scenario where you need to scrape data from multiple websites concurrently to gather information for analysis or reporting. By using Python's threading or asynchronous programming libraries, like Asyncio, you can create multiple threads or tasks to fetch data from different websites simultaneously. This approach significantly reduces the overall time taken to scrape data from multiple sources compared to fetching them sequentially. Concurrent web scraping in Python not only improves efficiency but also allows you to retrieve real time data from various sources in parallel, making it a powerful tool for data aggregation and analysis in a variety of industries. Concurrency in Python enables developers to harness the power of parallel processing, leading to more efficient and scalable solutions for a wide range of industrial applications. Keep learning, stay curious, and I'll catch you in the next video.